Greetings everyone, this is Not an Expert here back again with another video. Today we'll be solving problem number 26 and the difficulty it's rated at is medium. This problem was asked by Google, but I've seen it asked in a lot of other interviews as primarily like an icebreaker question. Alright, so let's just dive right in. So given a single linked list and an integer k, remove the kth last element from the list. K is guaranteed to be smaller than the length of the list, and the list is very long, so making more than one pass is prohibitively more expensive, and we need to do this in constant space and in one pass. So basically we need to do it in O of n complexity and with O of 1 space complexity. So fortunately we were able to find a pretty similar problem on LeetCode, and we'll be jumping right into it. Again, you can check out the link given in the description below, and try solving this problem on your own. But basically it says the same thing. We need to remove the nth node from the end of the list, and if we have 1, 2, 3, 4, and 5 as our linked list and n is equal to 2, so we need to pop out the second last element, which is 4, and then the output would be 1, 2, 3, and 5. Cool. So before we start, let's just write a few base conditions that if we don't have a head, we just return nothing. And the concept is pretty simple. We just have to use two pointers, and basically one pointer is going to be our fast pointer and the second pointer is going to be our slow pointer. So let's just define a few variables which do the same thing. And basically the fast pointer is going to be fast because it would have already traveled till n, or till the nth node. And the reason for that is basically if we traverse till the nth node, the difference between the slow and the fast pointer is always going to be equal to n. So let's just do that. Let's do a quick for loop which is till n, and all we need to do is we just need to keep on updating fast, right? There is one condition of what happens when you've already traversed and you're at the end of the list, right? In that case, that would only happen if you have given n equal to 5. So when n is equal to 5, you would be at this guy. And when that happens, right? When that happens, what we need to do is we need to pop out 1. So let's just make a quick check for it. We'll just say if not fast, basically if fast is none, then we need to return whatever's the value from the next of the head. Basically, we need to return 2, 3, 4, and 5. It's a pretty simple this thing. The reason why we're doing this is basically we are not given any condition which is saying that n is going to be less than the length of our linked list. So yeah, that's the reason why we're doing that. Cool. And the way we'll be progressing with this is basically we need to reach till the end or the last node, right? So we're going to traverse till the last node, till the fast pointer is at the last node. And though what we'll have at that particular moment of time is that 5 would be here, that would be the fast pointer, and the slow pointer will be pointing at the third node, and we need to pop out the fourth node. The way we'll be popping it out is basically we'll be saying that whatever value is at the slow, the next pointer is just going to be not the next, it's going to get updated to the next of next, right? Again, it's pretty easy to show it through code, so let's just write it. So what we're going to do is we're going to traverse till we hit the last node, right? Again, it's the last node. That's why we're doing it while fast of next exists. And if it does exist, what we do is we update fast.next and we update slow.next as well, right? And then after this traversal has happened and the fast node is at the last node, all we need to do is we need to update the slow pointer. So we say slow.next is equal to slow.next.next, basically updates it to the next element, and in a way our entire head is now updated accordingly. So if we do return head, we should ideally just return the entire head itself. Cool. So let's just write a few prints so that we get a better depiction of what we're trying to do. So let's just run this code. Hopefully it should run fine. So as you can see here, the fast pointer is presently at 3 and slow pointer is at 1. Then it gets traversed again to 4, that's a fast pointer, the slow pointer is at 2. And then when it sort of comes to 5, at that present moment of time, 5, there's no value after this guy, the last node. So it returns, it sort of breaks out of the loop. And basically what we're at is that slow is at 3 at that particular moment of time, and 5 is the first pointer. And now we just update slow.next. We just say, hey, 3 needs to not point towards 4, but needs to point to the next of next value, which is 5. So it just does that. And then when we return the head, we return the output as 1, 2, 3, and 5. Cool. Seems to be running fine. Let's just run this one more time just to check whether the output is coming correctly. It seems to be working fine. Let's just submit this solution, and hopefully it should run fine. Again, all we're doing over here is basically we've used this logic of having 2 pointers. One is a fast pointer and one is a slow pointer, and they're always going to have a difference of n with them, because we've already traversed, the fast pointers already traversed till the init uh, node, right? Again, this is 67% faster than all Python solutions. You don't really need to worry about all these things. These are just good to have. But you can see that our complexity is still O of n. And that's basically it. Cool. So that's it for today's video. This is a pretty short video, and I feel like this is asked like an icebreaker question most of the times. So if you're asked this question, you can like quickly solve it so that you can, get a good impression and get the interview. Um, Alright, so that's it for today's video. If you did like this video, do give a like and do subscribe. We are a discussion over here, and we'd love to have you on board with us. We are pushing videos on the daily, so it's going to be really cool if you're with us. Again, if you have any comments or if you have any doubts, you can write in the comment section below. And again, if you've already subscribed, you're awesome. We all know it, and have a great day. Thank you.